Good morning everyone. Let us now see about half wave rectifier. So the half wave rectifier converts AC voltage into pulsating DC voltage using only one half cycle. So here we use only one diode for the half wave rectifier. The AC voltage is applied to the primary winding of the transformer and is coupled to the secondary winding of the transformer, and the output is taken across resistance RL. So the AC voltage is converted to pulsating DC. We can see in detail. So this is a circuit, primary winding, secondary winding, we use a diode and the load. So here we give the input. Consider a cycle, one positive half cycle and negative half cycle. So consider the positive half cycle. So here the diode conducts for the positive half cycle and we get the same output as we give in the input. For the negative half cycle, the diode does not conduct in the reverse direction. Hence, I don't get an output during my negative half cycle. So I get my output only during positive half cycle. During the negative half cycle, I don't get the output. So for the input secondary voltage, I get output only for the positive half cycles. So consider the operation. So for the positive half cycle of the input AC voltage, the diode D is forward biased and hence it conducts. The diode becomes forward biased and it conducts. Now the current flows in the circuit and there is an voltage drop across RL. For the negative half cycle of the input, the diode D is reverse biased for the negative half cycle and does not conduct during the reverse bias. And no current flows through the circuit. So my current value will be 0, voltage value will be 0. Thus, for the negative half cycle, no power is delivered to the load. Coming on to the circuit analysis. Consider load current IL is maximum current Im into sin omega t for the time period omega t 0 to pi. And when omega t value is greater than or equal to pi to less than or equal to 2 pi, my value will be 0. So consider DC value of current is 1 by 2 pi into integral 0 to 2 pi load current IL into d omega t. So here we know that I have values for half-wave rectifier only for 0 to pi. For pi to 2 pi my value is 0. So we need to consider only for the integral 0 to pi. And for the value pi to 2 pi, my value is 0. So 1 by 2 pi into integral 0 to pi IL into d omega t plus 0. So my IL load current is Im maximum value of current into sin omega t. So integration of sin omega t is minus cos omega t. And limit I have 0 to pi. So taking this minus outside, so minus Im by 2 pi, cos pi minus cos 0. Cos pi value is minus 1, cos 0 value is 1. So already I have a minus here, so minus 1. So here if I take minus 2, minus outside, I will get 2 Im by pi. 2 getting cancelled, I get Im by pi. This is my DC value of current. So what is the DC voltage? V equal to I into R. So DC current is Im by pi into RL. So Im into RL, let me consider it as ESM, maximum value of voltage by pi. So we need to calculate the RMS value, the root mean square value of the load current. So taking same value, load current is equal to Im into sin omega t. So the RMS value of current is root of 1 by 2 pi into integral 0 to 2 pi, load current square into d omega t. Substituting the value of IL, load current is Im into sin omega t whole square. So we know that only we have value to 0 to pi. So taking Im square outside, it come to Im. What is sine square? 1 minus cos 2 theta by 2. 1 minus cos 2 theta by 2. Hence we get 1 by 2 minus cos 2 omega t by 2. Integrating this, I get omega t by 2 minus this cos will change it to sine 2 omega t by 2. 2 into 2 we get 4. So substituting the value, sin pi will be 0, sin 0 0. So first term will only be available. So that is pi by 2. Pi will be getting cancelled and Im root 1 by 4. So 4 when taking outside the square root we get 2. So RMS value of current is Im by 2. So now consider RMS value of DC load voltage. The RMS is I into R. So here RMS value we have calculated. Im into RL we can consider as ESM by 2. We need to calculate the efficiency. It is the ratio between DC output power to the AC input power. So DC output power we have calculated I square RL. I DC square RL, same way I RMS square into RL. Substituting both the values, I get my efficiency as 40.6%. We need to find the ripple factor. So it is the ratio between RMS value of AC component output to average value of DC component output. So the ripple factor is given by RMS value of AC component to the average value of DC component. So root IRMS square minus IDC square by IDC. So taking in the denominator IDC, substituting the values of all the known values, I get my ripple factor as 1.21. Next we need to find the peak inverse voltage. So it is a peak voltage across the diode in the reverse direction. So here the load current is ideally 0, but the diode is reverse biased and hence the maximum value of the voltage that can exist across the diode. So that maximum value is the peak inverse voltage. ESM, maximum value of secondary voltage. So that is given by pi into the DC value of voltage. Next we need to find the transformer utilization factor. It is the ratio between DC power to AC power. So here the DC power IDC square RL. Similarly for finding the RMS value, voltage RMS, we need to divide the value by root 2 or multiply it by 0.707. So the transformer utilization value is 0.287. We need to find the form factor. Form factor is the ratio of RMS value to the average value. So that value comes around 1.57. We need to find the peak factor. It is a ratio of peak value to RMS value. Peak value is Im, RMS value Im by 2. So here the circuit is simple. Only one diode is sufficient. No center tap transformer, hence the circuit cost is low. So disadvantages, they produce low output voltage and we obtain not purely DC but it contains lot of ripples. Efficiency is very low. The transformer utilization factor is low. The DC output current analysis exists in secondary winding of transformer. So in order to eliminate all this, we need to go for the full wave rectifier. So in the full wave rectifier, we use two diodes. So one diode will conduct during positive half cycle and the other diode conducts during the negative half cycle. So during both the cycle, I get my output. So this gives a better result when compared to half wave rectifier. Thank you.